Namaste. Welcome to Pythagoras Academy. In today's video, we'll try to understand the concept of acceleration. By definition, acceleration is rate of change of velocity with respect to time. For example, if you're driving a bike, you start a bike and give it some acceleration and you would certainly speed up. And when you apply brake, the speed is certainly coming down and ultimately the bike would come to stop. So what is happening in this case? You accelerate and you're speeding up. If you look at acceleration only through this angle, it can give you misconception about acceleration. Observe the first statement. If acceleration increases, the magnitude of velocity increases. If acceleration increases, the magnitude of velocity increases. Somehow, understanding the acceleration only at a surface level will make you feel that this is true, because you are giving acceleration to the bike and the bike is speeding up. So it somehow appears to be true when you give the statement the first read. And go to the second statement. If acceleration increases, the magnitude of velocity decreases. It appears to be false. It seems like false. And if acceleration decreases, if you are decreasing the acceleration, it seems that the magnitude of velocity will decrease, but it is given that if acceleration decreases, the magnitude of velocity increases. So you will think that it is not possible. And if acceleration decreases, the magnitude of velocity decreases. It appears as if this is true if you understand acceleration only at surface level. Now let us try to understand the clear meaning of acceleration with the following example. Say there is a block or a body which is moving with a velocity of 50 meter per second. The speed 50 meter per second says that it is moving so fast that it could cover a displacement of 50 meters in 1 second. The speed says how fast a particle is describing its motion, 50 meters in 1 second. And now say it has got an acceleration of 10 meter per second square. So 10 meter per second square is 10 meter per second. 10 meter per second square acceleration rate of change of velocity is 10 meter per second. It means that in 1 second the velocity will change by 10 units, 10 meter per second. Now this is the case where acceleration is in the same direction of velocity. It is like you are trying to run and somebody is pushing you from back. In that case, certainly you would speed up. So the reason why the body will speed up is not because of this acceleration, but because of the direction of acceleration with respect to velocity. Because acceleration is in the same direction of velocity, the magnitude of velocity increases, and after 1 second, in 1 second, the velocity should change by 10 units. So 50 becomes 60 meter per second. After 1 second, 60 becomes 70 meter per second. Now at this point of time, if the velocity is changed to 5 meter per second square, which is 5 meter per second, the acceleration still continues to be in the direction of velocity. So the velocity will continue to increase, but now the rate at which velocity is increasing is only by 5 units in 1 second. So 70 after 1 second will become 75 meter per second. After 1 second, 75 becomes 80 meters per second. This is the case where the acceleration is actually decreasing, but if you observe the magnitude of velocity, it is constantly increasing. The difference is, initially the velocity increased by 10 units, 50 to 60, 60 to 70, but later on velocity increased only by 5 units, 70 to 75, 75 to 80. The rate at which velocity has increased is decreased because acceleration has decreased. Because acceleration has decreased, what decreased is the rate of increase. 50 has become 60, but 70 has not become 80, instead it has become only 75. That rate of increase has decreased. Now if you observe the third statement, if acceleration increases, the magnitude of velocity increases. We felt it's wrong in the first read, but actually I gave you an example where the acceleration is decreasing, but still the velocity is increasing. So this is pretty much possible. There is a possibility of acceleration decreases and the magnitude of velocity still increasing. So this cannot be true. This cannot always be true. So these two statements are false. Let us go to another example. Suppose consider a block which is say moving with 40 meter per second, and it has got an acceleration of 5 meter per second square in its opposite direction, which is 5 meter per second per second. In this case, the acceleration is opposite to the direction of velocity. It's like you're trying to move forward and somebody is pulling you from back. In that case, certainly you would speed down. The speed will certainly decrease, and it is decreasing by 5 units in 1 second. That is the meaning of 5 meter per second square. So 40 becomes 35 meter per second, and after 1 second, 35 becomes 30 meter per second. At this instant, if the acceleration has increased to 10 meter per second square, which is 10 meter per second. Now the acceleration continued to be in the direction opposite to the direction of velocity. So certainly the velocity would decrease, but now the decrease is at the rate of 10 units in 1 second. So 30 becomes 20 meter per second, and 20 becomes 10, 10 becomes 0 after 1 second. So the body is coming to stop. If you observe this example, in this case, the reason why the velocity of the body is decreasing is because acceleration is opposite to the direction of velocity. Because acceleration is opposite to the direction of velocity, the velocity is continuously decreasing. And because acceleration is increasing, what is increasing is the rate at which the velocity is decreasing. It means that initially velocity decreased by 5 units, 40 has become 35. But later on, velocity is decreasing by 10 units, 30 has become 20, not 25. The rate at which velocity is decreasing is increasing because acceleration is increasing. Now, if you observe the first two statements, if acceleration increases, the magnitude of velocity decreases. So this appears to be false, but there is a possibility of acceleration increasing and magnitude of velocity decreasing. So we felt that if acceleration increases, magnitude of velocity should increase. No, it is not necessary. So the velocity increasing or decreasing depends on the direction of velocity with respect to acceleration. So if acceleration is in the same direction of velocity, the velocity increases, and if acceleration is opposite to the direction of velocity, the velocity decreases. So all these statements are absolutely false, because this condition that acceleration increases or decreases is not sufficient to judge what happens to the magnitude of velocity. The information I need is the direction of acceleration with respect to velocity to understand what happens to the velocity. Alright, so these two are very good examples to explain the concept of acceleration. Now if I rewrite the statement as if acceleration increases or decreases, the magnitude of velocity may increase or decrease. Will that be true? So if acceleration increases or decreases, no matter what, the magnitude of velocity may increase if acceleration is in the same direction, or may decrease if acceleration is in the opposite direction. Is the statement correct now? It appears to be correct now, but still it's false, because there is another condition of magnitude of velocity remaining constant. For example, consider a tree, and a person has tied himself to a tree and is running forward. So forward is like into the board. So tie yourself to a tree and try running perpendicular to the string. Move forward. In that case, the path the person would trace would be circular path. So this is the case where the force acting on this person is perpendicular to its velocity. So if there is a block which is moving with velocity v and acceleration is perpendicular to it, only the direction of velocity changes, but the magnitude will remain constant, because acceleration is rate of change of velocity. Velocity has got both magnitude as well as direction. So if magnitude alone changes, or direction alone changes, or both changes, then there is change in velocity, then there is acceleration which causes that change. That rate of change of velocity is acceleration. So only magnitude can change, or direction can change or both can change. In this particular case, if acceleration is completely perpendicular to velocity, only direction changes but the magnitude will remain constant. So there is also a case where magnitude of velocity may remain constant. So if acceleration increases or decreases or remains constant, there can be a case where acceleration is 5 meter per second square throughout. Even in that case, the velocity may increase if acceleration is along velocity, or may decrease if acceleration is opposite to velocity, or may remain constant if acceleration is perpendicular to velocity. And if acceleration is inclined at some angle with the velocity, now there are two components of acceleration, ax and ay. So you have to resolve this velocity acceleration into two components, horizontal and vertical. Now ax will change the magnitude of velocity and ay will be responsible to change the direction of velocity. In this case, both magnitude and direction of velocity changes. So this is the clear concept of acceleration. So all these statements are false. The correct statement would be if acceleration increases or decreases or remains constant, the magnitude of velocity may increase or decrease or remain constant. This would be the correct statement, because this increase, decrease or remaining constant will depend on the direction of acceleration with respect to velocity. So this is the concept of acceleration. Thank you.